Today we started talking about piecewise functions a little bit, and the way I pointed out to you to do it was basically to graph two separate lines or two separate functions, this one and then this one, and then restrict it to just the domain you needed. In other words, I'm going to take this and I'm going to treat it like it's two different equations. Instead of f of x equals, I'm going to say this is y equals x plus 6. That's a 6, not a b, by the way. So y equals x plus 6 looks a little something like this. There it is. Okay, and then the other one is flying all around, 2x minus 4. So y equals 2x minus 4. Looks a little bit like this. Or probably exactly like this. Except I'm being a little wobbly. So in other words, I've drawn the two lines as if they're totally separate functions. And then I'm going to go back and look at where I'm supposed to restrict each one of these two. So the top one there is the y equals x plus 6. So this function tells me that that's only going to be true when x is less than or equal to negative 4. So let's look at where x is negative 4. X is negative 4 right here. So you could kind of think of that as kind of cutting your graph right there. When x is less than or equal to that, it's this function, because this is x plus 6. So that means less than or equal to, I can make a solid dot because it includes it. But over here to the right of that is not less than or equal to, so I'm erasing the whole thing. The whole rest of the line is irrelevant because that's not when x is less than or equal to negative 4. Now for the other function, 2x minus 4, that's only true when x is greater than negative 4. So here's negative 4. Okay, so when x is to the right of that, that's when it's this function. It's only to the right of it, not or equal to. So there you go. So this is what number 44, I think that is, looks like. And that's how one way of doing it is to graph both of them and then modify it according to those domain restrictions that we have, those conditions or parameters is sometimes what we call them, right here. Now, there is another way to do it. And you can do a little bit of both, depending on the equation or, whatever works best for you at the time. Another way to do it, excuse me, is to take each of these and make a table of values for each one of them, like they're separate functions. So in other words, like this. If I had 3 pieces, I would have 3 tables of values. I have 2 pieces, so I make 2 tables. Now the key thing about this is that we are only going to use x values that match what it says about the domain of that part of the function. So in other words, for x plus 6, I'm only going to use x values less than or equal to negative 4. So like negative 4, negative 5, negative 6, and so on. And it says less than or equal to, so less than goes on forever, so it could keep going forever here. So then I'm going to go ahead and negative 4 plus 6, that's 2. Negative 5 plus 6 is 1, and so on. Okay, so that's one part of my graph is going to look like this. I'm going to use those points to plot one portion of my graph. Matter of fact, let's go do it. Okay, we had, there it is. Okay, negative 4, 2, negative 5, 1, and so on. So negative 4, 2, negative 5, 1, and it keeps going forever this way. Now I did take note before I started doing it of the fact that it's less than or equal to, so at negative 4, 2, I have a complete filled in circle. Now I'm going to go ahead and do the other table of values here. Now in this one I'm only going to use x values greater than negative 4. And I say that, but then you're going to see me write this. But let's go up from there. Greater than negative 4 is negative 3, negative 2, negative 1, and so on. and going for a while. The reason I include -4 is because I'm going to need an open circle there. I need to know where there is in order to draw an open circle there. So I might make a little note to myself. This is not really on my graph. This is an open circle. So 2 times -4 is -8, minus 4 is -12. 2 times -3 is -6, minus 4 is -10, and so on and so forth forever. So here's the other part of my graph. I'm going to start with an open circle on -4, -12, and then I'm going to go to -3, -10. Let's see, -4, -12 is down here. Open circle down here. -3, -10 is right here. Then next, and so on and so forth forever. So it's going to look like this. Ends up looking exactly the same way, regardless of which of those two ways I do it. But a lot of times it is easier to graph it using this method, which is to make a table of values for each one of the parts of the equations and only fill in domain values that fit what I'm told over here, with the exception of if it's an open circle, I'll go ahead and find out where that location is so that I know where to draw my open circle. Happy homework!